Okay, so in today's video we're going to use a recurrence relation to model an annuity. So this is Year 12 General Mathematics, Unit 4, Topic 1, Loans and Investments, and Subtopic 3, Annuities and Perpetuities. So let's look at which syllabus descriptors we're covering in today's video. So use the recurrence relationship to model an annuity. So a to the n plus 1 equals r times a to the n plus d. And investigate numerically or graphically the effect of the amount invested, the interest rate, and the payment amount on the duration of the annuity. But what exactly is an annuity? An annuity is a form of compound interest investment into which regular and equal payments are made periodically for a fixed period of time. Or it's a single sum investment from which regular and equal payments are received. The interest in the annuity is compounded at the end of each period before the payment is made or received. So superannuation is a fantastic example of an annuity. So employers make regular contributions on behalf of their employees at 9.5% of their wage into their super fund. So the interest on this investment compounds, and then the annuity is set aside until they retire. So superannuation is a fantastic example of a growing annuity. Mortgages and car loans are other examples of annuities, but in these cases the regular and equal payments are subtracted from the loan, from which compound interest is added. So we covered this when we were looking at our reducing balance loans in our last few videos. So let's check for our understanding of what an annuity is. So which of the following are examples of annuities? $5,000 is invested into a savings account with simple interest of 5.85%. Is this an annuity? Well, let's go back to our definition. So it's compound interest to which regular and equal payments are made. So no, this is not an annuity. It's a simple interest account, so there is no compound interest and no regular payments. What about number 2? $2,000 is invested into an account, compounding monthly. At the end of each month, additional contribution of $150 is made. So, is this an example of an annuity? Yes, of course it is. So here we have our investment that's compounding monthly, and it has regular and equal contributions of $150, being paid per month. Next one. Mortgage repayments of $1,750 are made on a home loan of $250,000. Is this an annuity? Yes. So we even said that mortgages were great examples of an annuity. So here's our single sum invested, and these are our payments that are being deducted from the account. Withdrawals are made from an investment sum of $500,000 when needed. Is this an example of an annuity? No. So although we have a single sum invested of $500,000, the payments that are coming out say when needed. So they're not regular and they may not be the same amount. So this is not an annuity. So let's look at using the recurrence relation for modeling an annuity. So here's our recurrence relation. So a to the n plus 1 equals r to the n plus d, where our starting amount is a. So where r is the compounded interest rate per period, a is the value of the annuity at the end of the first payment, or it's the initial investment, and D is the repayment amount. So if we remember back to our reducing balance loans, we had the same general formula, only we had take away R instead of adding D. So let's go through an example. At the end of each year, $1,000 is invested at 5.75% per annum compounded annually. Set up the recurrence relationship that represents the value of the annuity after each payment is made. So we start by writing down what we know. A0 is 1,000. Our R is 1 plus 0.0575, so I've changed that into a decimal. It's compounded annually, so I don't have to divide by any number for the per period. So my R value is 1.0575. I'm making regular payments of $1,000. Here's my general formula, and then I've substituted in. So my R value times A to the N plus my repayment of D and where I'm starting. Now question 2 says, using this recurrence relation, find the value of the annuity for the first 4 years. So first I type in 1,000 into my calculator and press enter, then times by the R value of 1.0575 plus 1,000 for my D. 1, 2, 3, 4. So the end of my first year is $1,000. The end of my second year is $2,057.50. The end of my third year, $3,175.81. And the end of the fourth year, $4,358.42. So the values of the annuity, the first 4 years, $1,000, $2,057.50, $3,175.81, and $4,358.42. Okay, so now it's time for you to do some individual practice. So I want you to go to page 306 of your textbook, exercise 9.3, and do all the questions except for the ones that say using technology. So when they're saying that in this chapter of the textbook, they're wanting you to use a spreadsheet. So we're not going to do that today. Then I want you to complete the study on questions for chapter 9.19, concept 1. And remember, make sure you end any previous sessions first, so that it'll load the questions from concept 1. I want you to copy down the summary and how do we know where to go. Remember, we're looking for this green icon with the tick sign to start those questions. So I want you to pause the video now, answer these questions from your textbook, go to study on and answer the questions. So pause the video now. Okay, so I'm assuming if you're continuing to watch that you have either completed those questions or you're having difficulty doing them and want to work out what you did or didn't do right. So our first question, looking at concept 1, says complete the following table using the repayment made, interest charge, reduction in principal, and the loan balance. So our starting balance was $30,000. Our interest rate is 5% compounding monthly, so that'll be 0.05 over 12. And our repayment value is $200. And the first month is filled in for us. So we can see this $75 is $200, take away the interest, and that's what's being principal paid. And that is what's coming off the loan. So we can see here that this is our $30,000 take away our 75. So here I've set it up in Excel. So I've got 200. My interest is 0.05 divided by 12 times by $29,925, which will give me my $75.31 when I subtract these two together. Take it away from my previous balance. I get $29,849.69. My next lot of interest is 0.05 divided by 12 times that to get 124.37. Subtract these two together to get my 75.63. Take that away from our previous balance, and there's my table filled in. Question 2. Using the annuities recurrence relationship, calculate the value of A3, where the principal is $25,000. Our interest is 6.3 per annum, compounded monthly, and we're making payments of $450. So set up my information. There's my principal. Here's my R value, 0.063 divided by 12 because it's compounded monthly. I'm making payments, and it's take D there, so going to put a negative sign. And so there's my recurrence relationship. So I have to work out the value of A3. So A0, A1, A2, A3. And remember, to do this on your calculator, you press 25,000, press enter, and then times 1.005467, take 450, and you press enter 3 times, and you'll get your. So our answer here is A. Question 3. Using the annuities relation, calculate the value of A2. But we're not told where we started. We're told the value of A3. So we have to work backwards to work out what A2 is. So A3 will be our R value times A2, take away D. So let's write down what we know. So 6.2% compounding monthly. Here's our interest rate plus our R. Here's our general formula for the recurrence relation. Our A3, we're going to substitute in for that. Now we know that A3 is 150,000, so we put that on this side. Now we have to solve for A2. So I've got take 1100, so I take it to the other side as plus 1100. So 151,100 equals the interest rate plus R times by A2. So if this is a times sign on this side, when I take it to the other side, it becomes divide by. So A2 is 151,100 divided by our R value, which gives us $150,323.33, which is C. Okay, question 4. Interest is paid monthly into an account at 3.5% per annum. Each month, immediately after the interest is paid, the account is debited by $10 in fees. The initial value of the investment is $1,550. Calculate the balance in the account at the end of 2 months. So here's our starting value. Here's our R. We're taking away $10. And here's our recurrence relation. So that's our starting amount. Our end of our first month, it's gone up by the interest rate. At the end of our second month, it's gone up again. So the end of our second month, it's D. Okay, last question in this section. So, which of the following investments is not an example of annuity? So, we'll read through them first. $1,000 invested per year for 10 years at 8% per, interest compounded annually. B, $10,000 invested at 6% per annum for 10 years with interest compounded annually. $100 invested each week into a bank account paying 7.2% per interest compounded quarterly, and $1,000 invested every 6 months for 2 years at 8.1% with interest compounded monthly. So if we remember our definition of annuity, it is form of compound interest with regular and equal payments. So A has a single sum with $1,000 regular payments, so it is an annuity. Our C is also an annuity, so we've got $100 invested each week, so there's our regular payments and it's compounded. D, $1,000 is invested every 6 months, so there's our regular payment, compounded monthly. But B, we just started with $10,000 invested, so it's compounded, but there is no regular payment. So it is not an annuity. So the answer is B.